how does an engine work anyway? Okay, now you might notice for your own, when I give you handouts that's got words and stuff on them and pictures, it's a good idea to hang on to those handouts because, why, Joe?
Because you can always look back over them and study. And
you got your final exam, there may be some questions off of here, and so if you've got these, you can look at them. An engine is a big air pump. That's all it is. So if you got a 4-liter engine, it's going to move 4 liters of air during a full cycle. If you turn the crankshaft 2 times on a 4-liter engine, and if you could catch all of that air, you would catch 4 liters of air. Now, what's the difference between the amount of air that it's actually capable of moving and the amount of air that it actually is able to move when it's running dynamically? It's not going to be able to move 4 liters of air every 2 crankshaft revolutions because of a principle called, does anybody know, have you heard of volumetric efficiency? Because the air's got to go and make a lot of turns on the way in there. Here's something else I want to hit you up with as we're talking about this. The manifold on every vehicle is set up so that every cylinder gets an equal amount of everything. That's why on some, even on the old carbureted manifolds, it looked like they made everything look like spaghetti, you know, going here, there, and yonder. And do you know the reason, as far as we're talking about intake there, but on the other side you've got exhaust manifold. Okay, so your exhaust manifold, the old cast iron exhaust manifold like we got on the 350 out here, is not as good as what we call headers. And any of you people that have fooled with Volkswagens, and Joe is, you know, Volkswagen bust and he likes to tinker with Volkswagens, what do they call the headers they make for a Volkswagen? Extractor exhaust. Why do they call it extractor exhaust?
The way the engine moves, those, like, the exhaust just gets pulled out of it. Well,
you're using the word to try to explain it, but what happens is you've got a bunch of pipes that are all the same length, and they actually go into a collector. And because they go into a collector, the exhaust coming out of every cylinder creates low pressure that helps draw the air out instead of it having to push it out. You got me? That's why headers give you a little bit more power, because they actually draw the exhaust out instead of, and vehicles, some of them like Jeep Cherokees come with headers on them. They're made with headers, right? Mustangs, a lot of them have got, you know, little headers. And hey, Lundy.
Sorry I'm late.
It's okay.
Headers for my truck. Because they would work better for the exhaust system I'm about to put on it.
Okay, I'm going to tell you a little story now, because I like to tell stories. Have you anybody picked up on that?
I did.
I had a 74 Ford pickup truck. And on that 74 Ford pickup truck that I bought, I was driving along and it cost about $2,000. Well, I saw it sitting beside the road with a for sale sign on it. The guy wasn't there. I said, I'll give him $2,000 for that truck. It was a 74 model. This was in 1978, and the truck was in good shape. And so he calls me up, and he said, you left your phone number for me on my screen door. And I said, yep. I said, how much you want for that truck? He says, I'll take $2,000 for it. Well, that's what I told him I'd give him for it. So I went and paid him $2,000 for the truck, and I drove it away. And the first time I filled it up with gas, I had to spend, man, it was rough. I had to spend $6 to buy a tank of gas for that doggone thing. It was bone dry empty, and I'd been driving a little Volkswagen Squareback, and I was used to paying $3 for a tank of gas, and I had to pay $6. Oh, this was terrible. But anyway, by the end of that year, when Jimmy Carter got through deregulating gasoline, I was paying $1 a gallon for it without even blinking. You know, $1 a gallon was dreadful. You know, but anyway. I go out here and I'm driving this truck. When they went up to $1 a gallon, I knew I was going to have to do something, because the truck had a 302 column shift. It did have air conditioning, but I didn't always run the air conditioning. Didn't have any power steering, but it was getting 7 miles to the gallon. Best it could do. 7 miles to the gallon. That was ridiculous. And it ran good. There was nothing wrong with the engine.
What were the gear ratios on it?
They weren't like what you'd think. I mean, they had 332 gears in it. But I said, I think I'm going to try to put some headers on this thing. So I bought some headers, and I laid out there, and I put them on there. It was aggravating as all get out. And then I took it to a muffler shop, and I had them run, put nice mufflers and run it on out the back on both sides. And that was pretty cool. I mean, it sounded good. It gave me more power, but did it do anything for my gas mileage? It did nothing.
Another carburetor was on it.
Yeah, that little Motorcraft 2150 2-barrel. It wasn't a 4-barrel. It was just a little, Now, so I said, well, I heard somebody say, I was talking to the guy at Spence Battery up there, a big parts house, Delco parts house I used to buy parts from. They all had a machine shop and all that stuff. And he says, you know, I heard about this guy getting some screen, and they make these little gaskets that's got screens in them to go under your carburetor so it'll bust up the gas better. And that might help you a little bit. So me and him walked across the street to another place where they had all this little fine stainless steel screen. And I bought a piece of that. And underneath the EGR spacer, between a couple of carburetor gaskets, I siliconed a piece of screen so that all of that gas that was leaving that carburetor had to go through a screen on the way to the engine. Busted up a little better, right? So I said, okay, this is cool. It's going to bust the gas out. And it gave me more power, but it didn't help my gas mileage. The gas mileage was still 7 miles to the gallon. It wouldn't budge. All I was doing was going to a lot of trouble trying to get it to get better gas mileage. And I thought about rejetting the carburetor, but I said, well, what's that going to do, you know? So I said, okay, I know one thing that has to make a difference. There's no choice. And it had one of those Rockwell differentials, and we're going to be working on rear ends out here. But the Rockwell style differential had the pumpkin that went in the front. So you might see, if you look under a vehicle and you see that there's no differential cover to be removed because it's welded on there, that means that the gears and all come out the front. Take the drive shaft out, take a bunch of bolts out, pull your axles out, and the gears come out the front. Okay, and so I did that, and I went to the salvage yard. And I said, there's nothing wrong with these gears, but I want some that give me some road gear so I'll get a little bit of gas mileage. And so he says, okay, well, I've got a Ranchero out there with 275s in it. These are 332s, but you got to know if you got a 28 or a 29 spline or whatever, you know. So we counted the splines. Oh yeah, this will fit. Popped it in there, and that doubled my fuel economy. Going from 332 gears to 275 gears doubled my fuel economy. From 7 to 14. Now the speedometer was off, and I didn't want to pull the extension housing off and put a new drive gear along with the driven gear. With the driven gear, you change the number of teeth. Now, if I wanted my speedometer cable to spin faster, what I need to have a speedometer cable with more teeth or less teeth?
More teeth.
No, that would spin it slower. Well, anyway, it wasn't accurate. The speedometer wasn't accurate, but I was satisfied because I knew how much I was spending on gas, and it cut my gas bill in half. I was driving 32 miles each way to work every day. But here's the rest of the story. I was coming, and when I would drive in those days, I would drive all the way from up down Highway 69 and from between Beaumont and Port Arthur, and I would turn down and I would go down the highway to Sabine Pass. Go from through the Gulf Oil Refinery next to the ship channel all the way down there, and that's where I worked. On the way home, I would be driving back, and I would notice that I would be losing power. And I would keep pushing the gas pedal down, pushing it down, and I was only going like 50 miles an hour, and I was on the floor with my gas pedal. And I said, this is bogus. So I go up the Intercoastal Bridge right before you get to the Gulf Oil Refinery, and I'd let off my gas, and I'd coast down that Intercoastal Bridge, and by the time I hit the bottom of that bridge, all my power was back. And this was every single day if it was in the fall or the winter. It didn't happen in the summer. Okay, now, I'm not going to throw a bunch of parts at something. Typically if it's mine, I'm going to drive it and think about it. Unless it's doing something stupid like really putting me down beside the road, you know what I'm saying? But if it's something's happening intermittently like that, it's hard to troubleshoot. It's best just to reason it out a little while. Think about it, mull it over. Your mind's always got to be working anyway. If your mind is not always working, you're not going to get much of anything done, right?
This is the same truck, right?
Exactly the same truck.
Okay. And you said it was only doing it in the winter and spring?
Mm-hmm.
Oh, it's generally cooler in the winter and spring.
That follows, yeah.
So, did your truck have an electronic choke or anything like that on it, or?
Well, yeah, they had an electric choke on it.
Was it malfunctioning?
Nothing wrong with the choke. But I will tell you what I did do. When I pulled the regular exhaust off and I put the headers on it, that little paper hose that goes up to the breather snorkel, it had to go away because I didn't have a stove that would fit those headers. All right. Now that was part of it, but what the deal was, everything I had done had culminated in a problem, and I figured out as I thought about it that screen I put under the carburetor was icing up. Gas will freeze, and it was stopping up those little holes in that screen to where there would barely get any air through it.
So your carb never got warm, really?
Well, no, it wasn't. Well, it wasn't able to pull anything off. Well, what I did to solve that problem. I didn't take the screen out from under the carburetor because I like the rest of the stuff it gave me. I got one of those paper hoses and bent it around and just kind of crammed it in there amongst the headers. You know, so if the air coming in was too cold, that little door would close and it would pull hot air off the headers. That took care of that whole problem entirely. That's all I had to do to fix it. I mean, understanding how things work is everything. That's where I was going with that. You know, I was trying to fix a problem on my own vehicle, made a problem for myself, but I had to figure it out. But some people would just throw parts at something that's left and right and get really disgusted until they finally decide to sell the car and lose all that money they spent. I'm not going to play that game. Never have played that game, right? I had, you know, every now and then you make a mistake, but one way or another. Okay, now let's talk a little bit more. So 720 degrees of crankshaft rotation is a full cycle. 2 turns of the crankshaft carries every piston through 4 strokes, right? We're going to focus on what happens from just one cylinder, and it's a smooth bore that the piston travels in. You can follow me along on the words I'm saying here. A piston has 3 grooves around its crown usually, and it's got, see this piston? Here's a piston, 3 grooves around the crown. It's a brand new piston. And these rings are on here. These are compression rings, and this is an oil ring. The oil ring can be stuck and cause it to burn oil even if the compression rings are still good. But keep that in mind. You can have good compression, but it can use oil if this oil scraper, think of it as a squeegee. It squeegees the oil off, right? And whenever you get that, if that squeegee's working like it's supposed to, it's going to squeegee the oil off as that piston's going up and down. And incidentally, did you see that Facebook post about the new engine that Audi has come up with that's got the pistons actually operating rocker arms that are going to drive the and that's something to drive the crankshaft. The rocker arms are anchored on one side. It's a crazy thing. I put a picture of it and a little write-up about it that I got off Fox News. It's cool.
That just sounds like it's asking for trouble.
Yeah, well, I don't know, but it's actually smoother because there's not as much of this going on.
Mm-hmm.
Yeah, my buddy Matt Hussey over there at ProMaster, what he does is, you know how when you balance an engine, how you balance it, among other things, you weigh every piston and rod assembly so that they all weigh exactly the same. You take the lightest one.
You put little weights on the inside?
No. You take the lightest one and you match all of them to the lightest one. And what you do is, the inside of the piston, you drill a little bit of metal out and you keep weighing it until every piston weighs exactly the same. And every time he builds an engine at his shop, it gets balanced and blueprinted. And he's not far from Billy Pilcher, so anything else he needs done, Billy Pilcher can do. And I think Billy Pilcher could probably, it takes a big block of aluminum and makes engines from scratch, you know, because he's got all the stuff to drill and everything else. Yeah, probably $50,000 or $100,000 if you got it, you know, it costs as much as a house, yeah.
One of the reasons why the rotary engine can get such high RPMs is because it's not going back.
That's right. It's just going like this, going around and around. And one of the reps from Mazda, when I worked at Mazda, told me you won't blow one of those up if it's under a load. You know, and it'll turn 7,000, 8,000 RPM, you know. But anyway, I'm keep going here. This connecting rod right here is basically what's connected. You got a wrist pin here, this connecting rod, going down to a crankshaft throw, and it's spinning in some main bearings. You guys are going to get to tear some engines apart so you can see what's going on over there. Who's looking forward to that?
Me.
You like that? Yeah, all right.
I have a motor on my
Tear
Yeah.
the Escort again?
Huh?
The Escort again?
No, I'm going to give you a harder one this time.
What?
I got a Nissan
Yeah.
240 motor.
All right, so you got, it's got this hardened pin called a wrist pin. Now, back in the early days of the Volkswagen Bugs, they would actually, on some of the other engines, they actually put this in one piece and they put a roller bearing in here. And they assemble a crankshaft, and you can rev those things like there's no tomorrow, like 12,000 RPM or something like that. Yeah. But I mean, that's a lot of trouble. So it just works pretty good on this. Now, you got bearings in here, you know, between there and your crank that you can replace. You know, the little, I don't have one of those in my hand, I can show you. But in the olden days, they'd melt lead babbitt in there, and then they would shave it out, and you actually made the bearings. And they use that same stuff to do body work. If somebody made a dent in your fender, they'd clean it off and they'd melt lead babbitt in there, and then they'd shave it off and they'd paint it with a brush, and then they'd polish the grooves out from the paintbrush. That's before they had spray paint, you know, all kind of cool stuff they used to do. All right, as the crankshaft is turned by the starter or the power strokes of other pistons, the piston is drawn down into the cylinder to pull in the air and the fuel, and we call that concoction the mix, and then it goes back up to squeeze the air, gets hit by the explosion and the expansion of that air and fuel. Whenever the fuel, the the spark happens, it unites the fuel with the oxygen that's in that mix, and during that uniting, you wind up with a burn around that. Okay, the spark plug fires, creates that. Now, typically, that spark plug is going to fire just before top dead center, and as the engine picks up speed, unless it's loaded, that spark has got to happen sooner and sooner because the fire only burns so fast. Okay, I'm trying to make this simple and quick so you'll pick it up. So burn it in. And remember what I'm telling you, because you'll need to explain this back to the rest of us. We'll have a board exam where you guys will get up here and all the rest of us will have to ask you hard questions about engines. Remember how they do in the military? That's good stuff, isn't it? Okay? All right, so the crankshaft, camshaft, and everything else is oiled with a pressurized oil or splash oil. What's the difference between pressurized? What's something in the engine is oiled with splash oil rather than pressurized oil? Got any idea? Huh? Sir?
Cylinders?
No, the bearings at the bottom are getting splashed in the...
Well, the bearings at the bottom are fed with pressurized oil, feeds through the crankshaft. It's drilled. What else is? What's oiled with splash oil? What about the timing chain? If it's got a timing chain, it's oiled with splash oil. And what about the valve cover? You know, everything under the valve covers has got splash oil all over it all the time. But there's oil coming up that way too.
Yeah.
If you got an overhead camshaft, you got pressurized oil feed coming up to all the spinning part of the camshaft, and there's a potential for an oil leak, like what you and Melissa are going to have to fix on that Dodge whenever Tim releases it to us. I mean, that's going to be up to him when we start on that, but when we get ready to start on that, it's going to be intense because you guys are going to have to hurry.
Oh, yeah.
All right. Okay, and you have to come early.
I know.
It's not going to really work all that well with her working afternoon and you working morning, except the fact that she may be able to follow up in the afternoon when you leave in the morning. Y'all work together pretty good, so that might be all right. So anyway, whole different system as far as the oil gallery. Each cylinder has a companion cylinder. Talk more about that in just a minute. There's usually 2 compression rings that ride in the top grooves. I showed you those a minute ago, machined into the piston. Now, what do you call these grooves that these are in? The grooves. Lands, L-A-N-D-S, right? What's in between there. Now, if you're talking about measuring ring, there's a difference between measuring piston ring end clearance and measuring piston ring side clearance. Do you remember what that difference is? If you're measuring end clearance, you're going to take the ring off the piston, you're going to put it down in the cylinder, you're going to push it down in there so it's straight, and you're going to measure the gap between the 2 ends of the rings. If you're ever building an engine for somebody, or you're just tinkering around at home and all this, and you don't measure that ring end gap, you may be making yourself a lot more work. You seen that before, Reeves?
We do.
Yeah. Now, if you don't do that, there's one boy out here that wanted to rebuild his little 2.8 liter engine in his little Camaro. And what he did was, he was just getting ready to put the rings on and put the pistons in. I said, wait a minute, let's measure your ring gap. We did. He didn't have any. If you don't have any, you know what that means? When you put it on there, it swells up, tightens up, and the engine quits running until it cools off. And then you crank it up, and it runs about 10 minutes, and it quits running again until it cools off. You can't drive anything like that. You got me? So what you need to do, you take a file, and you very gently take off some of the end of that ring and make yourself some ring gap, about 1/1000th of an inch, whatever the book calls for. All right, now what about side gap? Let's talk about ring side gap. I'm telling you this right now. I mean, encapsulating quite a bit, so you'll understand this.
That's when the piston's in there, and you're measuring how much clearance is inside.
No, you're actually going to measure the clearance between the piston ring and the piston. In other words, you want to see how much slop, how much the ring can slop up and down in that groove, right?
Okay.
Between the lands. So what you're going to do is you're going to take a little feeler gauge. This one here is not going to have any because this is a new ring and a new piston. But I mean, the one that you've taken apart, you can measure side gap and end gap. And I'm going to give, I think I need to give each group of guys an engine just to tear it completely down and lay all the parts out, right? And so that you can look and measure everything, because you guys need to really dig into this and get into it good. And I've got a bunch of engines over there, you know what I mean? So we can do that. I mean, engines that have never been torn down that we changed out, you know, and we've changed out quite a few engines in here even since you've been here, haven't we? All right, so one way or another. And also, incidentally, when you're putting these piston rings on here, you always want to make sure you put them on so that these gaps are on opposite sides of the piston. Because if you got them stacked, there'll be a compression leak right there, and that ain't good. All right. Incidentally, the newer engines have got lower tension piston rings. And because they got lower tension piston rings, they don't wear as much. It's easy for them to turn over. It works just as well. The older ones like those are high tension piston rings. Anybody ever heard an engine on a vehicle that was sitting out there, been sitting out there for a long time, a couple of years, and people try to start it and it wouldn't start and all that kind of stuff? You ever notice how when you're spinning it over, it goes, rah, 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 it doesn't seem to want to turn very fast. And the reason for that is the wall's all gone from the cylinder walls, and they're just dragging on dry cylinder wall. Well, if you pop your plugs out and squirt some power steering fluid, or some transmission fluid or something in there to lubricate it a little bit, or maybe even a little bit of motor oil, and spin it over, then it'll start spinning faster. And it'll make it a lot easier, So engines don't like to just sit. They like to actually be.
They're fickle pieces.
Huh?
They're fickle pieces.
They really are, and all that. Nothing. Vehicles don't like it either. Okay, so the oil rings are made out of a different material than the compression rings, and they're designed to squeegee the oil from the cylinder wall, most of it. So the control of air is done by what? Where does the air go after it leaves the air filter? Mr. Napper, what were we talking about on your car yesterday?
Oh, the throttle body?
The throttle body, the throttle plate. It goes past the mass airflow sensor. When it leaves the air filter, it goes past the throttle. If you were an air molecule, this is where you'd go. You can go in there and you'd travel through the intake manifold along with all the other air molecules, and then you'd find yourself going head first into one of those intake valve ports, but the intake valve is going to open. You'd slow down a little bit until the intake valve opens, then you'd pick up speed, but you'd run into a bunch of gasoline molecules that had been sprayed by the injector. Then you're going to go in there, and then when the spark light's off, unite with the fuel, and then as you expand, you're pushing the piston down. So you got to think about this. Most of the time, the piston is either being driven or it's coasting, because that fire all burns out by the time the piston has traveled. The crankshaft has only turned about 25 degrees on each piston stroke before that fire goes out. If you look at the cam sensor synchronization, the cam sensor makes its cut, sends its signal whenever on the ones that I know about, whenever the crankshaft has turned 25 degrees, or 24 degrees actually, past top dead center. That's when the cam says, okay, we can spray the next fuel. You don't want to spray fuel when there's fire burning, right? Not really a good plan. All right, now then. So, there are these valves. These little valves. I got a valve in here somewhere. I'm going to find a valve. Here's a valve right here. That's a valve. But the problem with this valve is it's bent. Because it hit the piston, because it was out of time and all that. And here's some valves. These silly little valves right here, this one's bent too. This one came out of a 2002 Toyota Camry, and it looks like something you'd get out of a Briggs & Stratton engine. Little teeny tiny valves, right? All right, so those valves are basically what lets this stuff, and I want to show you a video that's going to clear all this up. I'm talking about this just, as I go along here, and sort of a stream of consciousness thing led by my notes here that you also have a copy of. They got strong springs attached to their stems, opened by egg-shaped lobes called cams on a shaft that spins at half the speed of the crankshaft. Remember, the camshaft spins at half the speed of the crankshaft. Sometimes the camshaft drives the oil pump, sometimes the crankshaft drives the oil pump. So the oil pump is not always driven by the same shaft. But on a lot of engines it's driven by the camshaft, but on a lot more of them nowadays it's driven by the crank. On the Escorts you built, it's driven by the crankshaft. Remember that? Okay. The shape of those egg-shaped lobes determines how much the valves open and how long they stay open. Whenever somebody says, I put a cam, you know what I mean? I put a cam in there, what'd they do? What was the difference in that cam and the other one? What about it, Mr. Reeves? You got any idea? What's the difference between a high-performance camshaft and a plain old camshaft?
High-performance and a regular camshaft?
Yeah.
The high-performance usually, they usually spin a lot faster, not spin a lot faster, but
open the valves sooner, keep them open longer. Lift and duration. Lift is how far it opens the valve, duration is how long it keeps it open. Got that? Alright, now then, camshaft opens a valve, and it's driven by the crankshaft with gears, a chain, or a belt. Whenever it's driven with gears, they have to take special measures to keep those gears from rattling. Because if you ever turn the camshaft, it goes doom, 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 doom. And it does that same thing. The belt takes up that noise. The chain basically can take up that noise. But if you got gears and they've got any lash at all, you're going to hear every last little clackety, clackety, clackety. It's a nasty, loud mess. And they actually, on Toyotas and some of the other ones, they have scissor gears. They got one gear split in two with a spring in between there that pinches those teeth. And if you don't put a bolt in there and keep that scissor gear loaded, and you put it back together and the scissor gear is unloaded, it's going to rattle up a storm under that valve cover. I can actually demonstrate on that Toyota engine on the stand out there. Okay, when the intake stroke, piston's traveling down, air's entering the cylinder, the intake valve opens, it closes when the pistons travel as low as it'll go. the piston rises into the cylinder, connector rod pushing it, and so it squeezes the air and fuel mix right before it reaches the top, usually about 10 degrees, or if it's spinning faster, it can be as high as 50 or 55 degrees before top dead center. The spark plug fires, and that ignites the mix of the air and the fuel, and there's your controlled explosion, and slaps the piston pretty hard as it's starting right down on its power stroke, and that happens really fast. Now, a diesel engine actually squeezes the air a whole lot more. The compression is a lot higher, and the heat of the compression is why the fuel fires, but that fuel burns all the way down. You remember I told you how many degrees before the fire goes out on a regular gas burner? 24 degrees. That's not very much crankshaft rotation, is it? So basically you're slapping every piston. You're just slapping them. But on the diesel, you're pumping them. That's why diesel's got such legendary torque. Some of those diesel engines in these pickups now have got, you know, between 500 and 800 pounds of torque. I mean, they're really powerful. They can really, you can move stuff if you got torque, okay? Now then, what about them there companion cylinders? Engines with even numbers of cylinders will have two of their pistons moving together. On a 4-cylinder engine, pistons 1 and 4 are at top dead center simultaneously, while 2 and 3 are at bottom dead center, which is 180 degrees of a crank rotation later, and 2 and 3 are at top dead center. So you're going to see the pistons 1 and 2, which are not companions, doing this on a 4-cylinder. If you look at 1 and 4, they're doing this. 2 and 3 are doing this. But while they're doing this, you know, the other ones are doing this. So you got the ones in the middle doing this, and they're actually opposite of the other ones. And that 4-cylinder engine only has a firing event, how many degrees? How can you determine how many degrees of between firing events? I'm taking 720 degrees, and I'm going to divide that by the number of cylinders, and that's giving you how many degrees between firing events.
For each cylinder.
So yeah, so how many? 4 into 720 is. Come on, I need a math whiz. Huh?
180.
Yeah, 720 degrees divided by, 180 is 180 degrees between firing events on a 4-cylinder. How about a 6? Yeah, it's not difficult, it's 120 degrees. Think of a pie cut in 3 places, you know, equal thing, 120. On an 8-cylinder, they fire like every 90, which is 15 minutes on the clock. Got it? Remember that. This is basic engine stuff. You need to know this too. Okay, so the harmonic balancer is a weighted wheel on the front of the engine, and that's the pulley that drives the belts. It's either bolted to it or part of it, and that weighted wheel is marked so you can find top dead center on cylinder number 1. But if you're not aware of where the camshaft is, it only takes 1 round of the crankshaft. I mean, the camshaft only makes 1 round for every 2 rounds of the crank. So if you were looking to see if an engine was in time, let's say that you're thinking an engine may have jumped time, right? And let's say it's got a rubber timing belt, and you can actually see that timing gear, and you know where the mark is that they're supposed to line up with when it's in time on the timing gear. I'm going to take that, I'm going to ignore the crankshaft entirely, and I'm going to turn that engine. If the camshaft doesn't move when you turn the crankshaft, you know the timing belt's jumped.
Oh, yeah.
I mean, destroyed. But if it is moving, I'm actually going to move it until the camshaft mark is lined up where it's supposed to be. Because every time that camshaft mark comes around, that crankshaft mark's going to be lined up. But if you look at the crankshaft, when you line it up, you got a 50-50 chance of the top of the camshaft being lined up. So you got a 100% chance of it if it's in time. So if I line up the camshaft and the crankshaft is not where it's supposed to be on number 1, I know it's out of time, and I know it's timing belt time. Now you know the difference between a free spinning engine and an interference engine. If the timing belt jumps on a free spinning engine, it doesn't hurt the valves. If it jumps on an interference engine, you bend valves all over the place, and the heads have got to come off. Got me?
Yeah, like the Eclipse motors.
Yeah, any of the ones like the Kias and the Mitsubishis, they like to bend valves when they jump time. If you got a Kia Cephia and you're driving that thing and it jumps time, and it'll do it. If it's supposed to, if the timing belt replacement interval is 100,000 miles, and you go past that much, you're living on borrowed time. And I had one couple that sent me an email through my website, and they says, you know, we only got 108,000 on it, and the timing belt's supposed to be changed at 100,000, and now we've got a $3,000 repair bill because it jumped time and it snapped the heads off valves, and the piston was still moving, and it just beat all that stuff up, and it just ruined the motor. We had one in here like that did that. We had to put an engine in it, of course.
Green one?
Nah, it was before you were here, but we had to put one in there. Okay, so how are we going to find top dead center? on a cylinder. Like if I want to find top dead center on cylinder number 1, and I want to make sure I'm on compression and not exhaust, how do you do it?
Take the spark plug out.
Huh?
You take the spark plug out.
You can do that, and then what do you do after that? Simply taking the spark plug out this is a good start, but
Right.
I want to find TDC on another cylinder besides number 1.
Usually put a coat hanger or something in there.
Here's the deal. Watch this. If you can pull it up on number 1 first and determine your own compression stroke, right? I'm basically going to, if it's a 4-cylinder, how far do I need to turn that crankshaft before the next cylinder in the firing order is on top dead center? 180 degrees. But you have to be accurate with that 180 degrees. You can't guess at it, right, if you want it to be right on. Why would you even need to know this? What if I'm doing a cylinder leakage test? Got me? Cylinder leakage test is basically you want it where the piston's up, both valves are closed, you put air in there, you want to see where the air is going. That ain't complicated, is it? It's really simple. And we actually have a worksheet, and I'm going to give you guys where you got to do a cylinder leakage test on one of these engines out here. You know, so are you paying attention? All right. If you know how many degrees there are between, but you're going to have to figure out a way. How would I do that, by the way? If I wanted a 6-cylinder and I wanted to know, and I wanted to make 3 marks 120 degrees apart, would I have to use a protractor or? There's a bunch of ways you could do it. I want to take something I can measure with, like a cloth tape measure or something like that, and I'm going to measure the circumference of that darn thing, and I'm going to cut it into 3 or 4 if it's an 8-cylinder, and then I'm going to start, and I'm going to go that many inches to make me a mark, that many more inches to make me a mark, and I got my marks I need. See, after you've done that, you can go poof and let it push your finger and bring that other mark up. You see what I mean?
Just follow the firing order.
Yeah, follow the firing order. There you go. There's a ton of stuff. I could keep going and on about this engine stuff. But the long and the short of it is, there's a ton of stuff. Now, I want you to take your test. Let's look at our test now. And we're going to see how much you guys have retained. Okay? Somebody tell me the camshaft spins at... Okay. Did you hear that? Did everybody hear that? At blank crankshaft speed. Even numbered cylinders have 2 cylinders that move together. These are generally fired by the same coil. That's if you got coil pack ignition like you see on that board over there. And they are called what? Okay, very good answer, guys. The crankshaft is driven by what?
Pistons.
Well, it's the blank and the blank.
And the starter.
Okay. And sometimes teeth shear off flywheels, right? Okay. The camshaft is driven by what?
Crankshaft.
Gears turning the boat.
There you go. That's a good answer. Number 5, piston number 2 of a 6-cylinder 4-stroke cycle engine piston has a firing event every 180 degree. And, yeah. As a well, no. Think about it. It's piston number 2 of a 6-cylinder.
120.
Yeah. So you're not. Don't go
This
confused.
is what I was thinking.
Yeah. You saw a 6 and a 4 and a 2 there, and it's going to confuse you.
No, what I'm saying.
Wait a minute. How many degrees between the firing events on a Briggs & Stratton 1-cylinder lawnmower engine?
A 1-cylinder?
Yeah.
Is it a 2-cycle or 4-cycle?
4-cycle.
Then it's going to be every 2 revolutions.
So that would be how many degrees?
720.
720 degrees. If it's a 2-cylinder.
2-cylinder?
Yeah.
For every firing event?
Yeah.
It's going to be 180.
360. 360. There you go. All right.
See, what I saw on number 5, it says piston number 2, a 6-cylinder 4-stroke engine cycle has a firing event every.
Yeah.
So it's just talking about one piston. So
Yeah.
it could be number 1, it could be number 4, it could be
Yeah.
number 6.
Yeah. You know, you're really smart. So every, and somebody said 180 degrees and they were right, and I called them down. So you're right. 180. It's going to have a firing order, isn't it?
No, I said 720 because it's that one piston.
Yeah.
And
Yeah, that's
it's
right.
Firing event every 720.
I was just really hoping I could get somebody to think in here. You know what I mean? You know, whenever you're taking a final exam or something, if you can show me in the book where you got the answer that you put, even if the answer key said it was wrong, you'll get credit for it.
So was it 180 or
It's well, think about it. What I say about a 1-cylinder engine a minute ago. If it's a 1-cylinder engine, we're just talking about 1 cylinder. Doesn't matter how many cylinders you got. If you're just talking about one piston, it's going to be the same as a Briggs & Stratton one cylinder. And how many is that?
720.
720.
Because it doesn't matter if it's piston number
Doesn't matter how
2.
many cylinders, it doesn't matter how many pistons it has. Each one of them is only going to fire once in that 720 degree.
It's like a trick question.
Yeah, sort of, yeah, because you're actually doing all this math and everything. Valves are closed by what and opened by what?
Springs and loops.
Oh, very good. He's paying attention. There are 2 what rings and 1 what ring?
Compression and oil.
Yeah, compression oil. What's the force that causes air to enter the engine?
Suction.
That's something I didn't talk about. I tell them it's in the handout, but I didn't.
No, it's air pressure. Lower air pressure versus...
Atmosphere. Which you're right. I mean atmosphere. And you know the difference between PSIG and PSIA, right? Yeah. You remember that?
Yes, I remember that.
You see PSIG, you ever see PSIG versus PSIA? I mean, we just all say PSI. But engineering is PSIG. You know what the difference between PSIG and PSIA is? Because you're going to see it in print.
PSIG, it's saying it starts at 0.
That's right.
PSIA,
No, wait a minute.
sea level.
Yeah, sea level is 0, which is actually 14.7, but that's 0 on a PSIG measurement. PSIA starts at no pressure.
Yeah.
So basically, it's going to be 14.7 pounds higher. That's an interesting little thing. You can ask most people what PSIG is, and they don't have a clue, unless they've been looking at my Technical Writer Facebook page where I post things, right? Okay.
Oh,
All right. The cam sensor tells the PCM what?
Everything.
Everything spray when the PCM is ready.
What about all of the above? Tells it where piston number 1 is, tells it when the next injector is going to spray, and it tells it that the crankshaft is going past a certain point. Let me say this. On some engines, you can unplug the cam sensor and it will start anyway. On some engines, you can unplug the cam sensor and it may start and it may not. On some engines, you can unplug the cam sensor and it will not start. Now, the cam sensor is not the same on every engine.
Didn't we have one of those on the spring semester that the cam sensor was unhooked? Yeah, you did it as a bug on me. I remember that.
Well, okay. All right then. The 4 strokes are in order what?
What's that?
If you're talking about the 4 strokes in order, what do you got there?
Intake, compression, power, and exhaust.
Intake, compression, power, and exhaust.
Always start with the intake.
Yeah, cool. Good idea.